Students, we are going to do the topic uniform circular motion. So this is a motion in which an object moves in a circle, and so what is uniform over here? Uniform is the speed. Speed is constant in the circular motion, uniform circular motion. So we have a constant speed written as v. Now look at this part of the circle. The object was at P and P dash at time t and t dash, and we have the position vector r and position vector r dash, and v be the velocity at P and v dash is the velocity at P dash, and the angle between them is between the CP, between the r and r dash is delta theta, and this is the displacement delta r. So bringing this velocity over here and this velocity over here, treating them as free vectors, this angle, because this angle is 90 degree, this angle is 90 degree, so the angle between them will also be delta theta. And using triangular law over here, triangular law of addition, we found delta r, and similarly we found delta v over here, and this delta v is perpendicular to delta r. So if I want to write average acceleration will be change in velocity from P to P dash divided by time taken, delta t. So the average acceleration is in the same direction as delta v. So if this is the direction of delta v, same is the direction of average acceleration also, because we have positive sign here, positive sign, same sign, same r, so both the vectors are in same direction, and this delta v, this direction is bisecting this angle delta theta. So if it is bisecting this angle, it means that this is also perpendicular, so this is the chord, so this will pass through the center, and now if we take the limit delta t tends to 0, then this average acceleration will be changed to instantaneous acceleration by taking the limit delta t tends to 0. Now if I am interested in the magnitude of acceleration, then I can write it as limit delta t tends to 0 delta v by delta t. Now we can see this figure A and figure B. So this is the point P over here, this is P dash, so P is bringing near and ultimately at P, so time is reducing, and here delta t tends to 0 in this figure. So limiting delta t tends to, so limiting the value, and so limiting this value delta t tends to 0, so this is the instantaneous acceleration, and I am interested in the magnitude of this acceleration. So we can see from these figures that uh, there are similar triangles CP P dash and this one. So GHI and CPP dash are similar triangles, so therefore their corresponding sides have same ratio. So taking delta V over V, so delta V over V is equals to delta R over, so the radius is capital R of the circle. So I am taking, so due to similar triangles, their corresponding sides are in proportion. So I can put this value of delta V over here. What do I get? So putting this delta V over here, I get A is equals to limit delta T tends to 0. So this V will go that side. So V delta R upon R. So that's the value of delta V. And so delta T is also there at in the denominator. So this is the magnitude of the acceleration. Now as V by R are constant, so taking them outside, this is V by R and limit delta T tends to 0, delta R by delta T. Now what is the value of this delta R by delta T? So we can see here that as delta T tends to 0, here delta theta will also tends to 0. And we can see that this P dash will come over very near to P. So PP dash, so this arc will become a line segment delta R. So this PP dash will be nearly equal to the arc will be nearly equal to the delta R. So these are the assumptions that we take in physics when we go very near to the circle. This arc behaves as a straight line. So now what this delta R equals to? Delta R will be equals to, so distance is equals to velocity, speed into time. The speed into time, magnitude of velocity, speed into time. So putting this value of delta R over here, what do I get? I get acceleration is equals to V by R, or we can also do one more thing. What we can do is, we are interested in delta R by delta T. So let us find the value of delta R by delta T with limit delta T tends to 0 over here only. So limit, so first of all let us write delta R by delta T. So V equals to delta R by delta T, and obviously this velocity, this speed is average speed, and instant is both, because speed is constant. So it doesn't matter whether I put average over here or not, because speed is constant. But still, this, if this is average, so it becomes instantaneous when limit delta T tends to 0. So now this value I have calculated over here. So this whole is V. So A is equals to V R into V, and this is the centripetal acceleration, whose it's center seeking towards the center. So this is the centripetal acceleration. I can write it as AC. So center loving, center seeking, V square by R. So this was the magnitude I was searching for. So this is the magnitude, and the direction of acceleration is towards the center all the time. Now, if I want to introduce one more term, which is delta theta. What the delta theta is? So delta theta here is the angular distance. So angular distance is equals to delta theta. So now what will be angular displacement? So angular displacement. So we can define angular, we can also say it angular displacement, this delta theta. So in terms of so this angular displacement, so we will have angular velocity. So angular velocity will be equals to angular velocity, or you can say angular speed. So if I am writing only magnitude, I can write it as angular speed. So angular speed is equals to distance upon time. So that is delta theta by delta t. So I can write it as angular speed as omega. So that's the symbol, Greek symbol omega, that is equals to delta theta by delta t. Now if I talk about one revolution, then delta theta will be 2 pi radians and delta t will be time period, one time period for the revolution, and 1 by t is frequency. So even if I don't write anything here, it means it is radians. If it is degree, I need to write the symbol like 360 degree, I need to write here. If it is 2 pi, I need not to write here anything. So that is radians. Now this 2 pi upon 1 upon t is frequency. So that's still omega. And here, as I'm writing it in terms of frequency, so so if I write it in terms of angular distance or displacement, then it will be angular speed, and if I write it in terms of frequency, then it will be angular frequency. So that's the point. Now what is the linear speed? So linear speed, v equals to delta s by delta t, and this delta s here is, so this delta s length of this arc is equals to r delta theta. So this is equals to r delta theta by delta t, and this delta theta by delta t is nothing but omega. So this is equals to r omega. So that's the relation between, that's a very important relation between linear velocity, linear speed and angular speed. And if I tell the direction also of this omega, then it will be angular velocity. So speed with direction. What is the direction? We can give the direction of the angular velocity with the right hand thumb rule. So place the fingers of your right hand in this direction, curl them in this direction, and your thumb will give you the direction of the angular velocity. So the thumb will be upward in this case, and so direction of angular velocity is coming out of the plane. That's what angular velocity's direction is. So what I'm interested in uh, writing the centripetal acceleration in some more ways. So as I know that v is equals to r omega, so I can also write this value of omega in terms of 2 pi nu. So I can also write it as, so v is equals to, so v goes to r omega equals to 2 pi nu into r. So we have these two formulas for the velocity, and now we can put this value of so this is important equation number 1. I can say this is equation number, this was equation number 2, and this is equation number 3. So I can write the, from equation 1 I can write AC is equals to v square by r. So I have two values of v, so putting two values of v here, so I will get AC is equals to what is v equals to r omega, so this will be r square omega square upon r, so one r will be cancelled out and I will left with AC is equals to omega square r. So this is another important formula. I can write it as formula number 4. Now formula number 5, put this value of v over here. What do I get? I get the centripetal acceleration as 4 pi square nu square r square upon r. So r will cancel out and I will get 4 pi square nu square r. So a lot of formulas over here. I can use them as per my convenience. So students, thank you for watching this video.